Hello, my dears. I'm really happy to see you again. Today we are diving into some exciting topic in chapter 1. A very interesting topic, which is colligative properties. The colligative properties are four properties that depend on something which is called concentration of solute, but not the identity of the particles. So you should know the definition. The definition is really important. Okay, let me change the size of the page in order to see in a better shape. Okay, let's begin. Colligative properties are properties that depend on the concentration. Good. On the concentration. And instead of the concentration, it's okay to say number of particles. Number of particles. Okay, so they depend on the number of particles rather than the identity, not the identity. The identity, it means type of solid, if it's alcohol, sugar, or salt, or something else. Most importantly, we only need the number of the particles. Particles, that's all. Okay, so we have four different properties. The names like four different phrases. You should memorize the names very carefully. Okay, let's read them. The first one, vapor pressure lowering. Okay, I didn't say it vapor pressure. This is vapor pressure lowering. Be careful. The second one, freezing point depression. Don't say freezing point alone. This is freezing point depression. Be careful, my dear. The third one, boiling point elevation. Okay, it means raising. Lastly, osmotic pressure, or raising or elevation. Okay, so I will explain any of the following properties individually. So by the end of this video, you should know some of them. Of course, not all of them, because we need some extra videos, some extra lessons to complete all of them. Okay, but please be careful. These are something or one of the most important topics in chemistry. Okay, so make sure to not lose them. Let's begin. Look, why do we call them colligative properties? Why? Because they depend on the concentration. So this is a general question with a general answer. Anytime once you see something, why this one is the colligative properties? Why? You should know because it depends on the concentration, on the number of particles. It decreases and increases according to the increasing and decreasing concentration. Okay? Look, all of them are directly proportional. They are directly proportional with the concentration, with the number of particles. How? It means as the concentration increases, vapor pressure lowering must increase. Freezing point depression is increased also. Boiling point elevation increases also. Osmotic pressure raising increases also. Okay, you may often ask, Mister, is it okay if I say vapor pressure is increased? No. Okay, so you should know that there's a huge difference between vapor pressure lowering and vapor pressure alone. Look, the following phrases are increased with increasing concentration, but if I remove their second part name, you know, the relations will be changed. Example, if I say vapor pressure lowering is directly proportional with the concentration, but if I remove lowering, only vapor pressure is inversely proportional. Okay, freezing point depression is directly proportional with the concentration, but if I say freezing point alone, no, it's inversely proportional. But for the boiling point and osmotic pressure, we don't need anything like this. Okay, either with elevation or without elevation, they're going to be increased with the increasing concentration. Okay, be careful. So again, I'll repeat to you for the third time. Look, vapor pressure lowering is increased, but vapor pressure alone is decreased. Freezing point depression is increased, but freezing point alone is decreased. Okay? And the following things are increased by any meaning with the increase in concentration. Be careful. Okay? So let's read something as a general point. We'll need the following points for all of them. Vapor pressure. Mister, vapor pressure alone, it was inverse or direct. Vapor pressure lowering, it was direct. But vapor pressure alone, it was inverse. Okay? Vapor pressure, same thing true for the freezing point, are inversely proportional with the concentration. But if I say vapor pressure lowering and freezing point depression, they are directly proportional. Be careful. Boiling point and osmotic pressure with elevation or without elevation, they're going to be directly proportional. Good? Keep going. According to the vaporization power, we will classify substances into two main categories, which are volatile and non-volatile substances. The volatile substances are those in which vaporize easily. These are volatile substances. But the non-volatile substances, you know, they don't like to vaporize, to be vaporized easily. Okay? They need more energy to become a vapor. Good. So non-volatile substance is one that has little tendency to become a gas under existing condition. Good. About the following graphs, by the end of the section, you will know what is the idea behind of the following graphs. Wait. I have explained the following lines in a very nice detail, even better than this. Try to, So let's take the following property, which is vapor pressure lowering. I need a white page. Please try to draw the following graph with me. Or once you understood, then try to redraw the graph in your notebook in a very nice way. Use different colors. Okay? So, for all the properties, we will compare two things. For all the 4 points, we will compare two things. Solvent, pure solvent, of course, pure solvent, with the solvent containing solid. Solvent containing solid, it means solution. Very good. Solvent containing solid, it means solution. Okay? So we're going to compare solvent and solvent containing solid, it means solution. For all the properties which are boiling point, elevation, freezing point, depression, vapor pressure lowering, and osmotic pressure rising. Okay? So let's take the following terms for the first one, which is vapor pressure lowering. Be careful, please. Solvent containing solid, it means solution. Okay? And pure solid. Normally, we'll talk about water as the most abundant solvent on Earth, but it's okay to have something rather than water, like benzene or something else. Okay, the first one. Let's draw the graph. There I say it. Look, assume that this is a bath that is filled with water until this level. This is the level of solvent. Remember, we will compare what? Pure solvent with the solvent containing solid. It means solution. So this is the first case, which is solvent, pure solvent. Okay, assume that this is a pure solvent, like example H2O. These are molecules of H2O at the surface of the liquid. So the only available particle in this liquid is the particles of H2O. Good. So now let's try to warm, to heat the container. Heat the container like this. Once they approach enough amount of energy, they start to be vaporized. They like to escape because they gain enough amount of energy due to increasing kinetic energy. Okay? So the particle, there's no barrier in front of the particles of water, because we have only one type of the particle, which is H2O. So They will vaporize easily. So as a result, we will get more vapor. Here we have more vapor pressure. Very good. So from now on, mister, that means vapor pressure of pure solvent must be high or lower compared to the same solvent containing solute must be higher, must be greater. So for the solvent, we have more vapor pressure. Okay, so now let's repeat the same experiment. This time, I will use the same solvent, which is water, but this time, it must be contained with some solid. So I will say H2O, assume that we have H2O plus sugar, any type of sugar, no problem, because all are electrolytes, so you know they behave the same. Once they for their dissolution, they will behave the same. They will become the dissolved particle only. As I say, they will neither dissociate nor ionize in water. Good. So now these are particles of water again. I have to use the blue color for water. This is like a culture. Good. Okay, these are particles of water. This is also H2O. Larva. And now the particles of sugar, assume that the red particles are particles of sugar. These are particles of sugar. So as the number of sugar particles increase, the number of H2O particles at the surface of the liquid is decreased. Because we will replace some of the following particles by the particle of solid, by the particles of solid, of course. Okay? Look, if I increase sugar particles, H2O particles must be decreased. Because to increase this, we need to remove some amount of this. They must be replaced by sugar. So now here we have more solvent. Look at it. More solvent. But here, less solvent. Good. And now, if I try to heat the container by the same way, look at this. Again, they will try to become vaporized. But this time, are there greater particle of water as an available particles or less particles? Here we have less particles of solvent. Let's see. Look, this particle will vaporize like this, and this one also. So now, what's your expectation about the amount of vapor? Less vapor pressure. Less vapor pressure. Now, in conclusion, vapor pressure of pure solvent is higher compared to the same solvent but contained with solid. Good? Okay? So now, which one has a greater vapor pressure? Solvent containing solid, which is the solution, or pure solvents? Okay, which one? This one, pure solvent, has a higher vapor pressure. Very good. Why? Because as the number of solid particles increase, in proportion, number of solvent particles is decreased. So there will be fewer molecules of solvent available to become vaporized. By the way, this is a very right time to talk, to mention something rather than vapor pressure, which is boiling point. Please try to have this note. I know this is too early to talk about the boiling point, but you know this is a very right time. Look at this. What is the relation between the boiling point and vapor pressure? They are inverse. They are what? They're inverse. Okay? So, as the vapor pressure increase, boiling point is decrease. Look, what's the relation between the boiling point and vapor pressure? They're inverse. Okay? Look, here we have more vapor pressure, so boiling point must be less. How about this? We have less vapor pressure, so boiling point must be higher. Okay? Look, it takes more time. It needs more energy more energy to be boiled, this one. But here, because vapor pressure is very high, so boiling point is very low, it takes less time and less energy. So which one has, or the vapor pressure is greater for which one? This one. Less vapor pressure. Which one has a higher boiling point? This one. So less vapor pressure, more boiling point. High vapor pressure, less boiling point. It needs less energy to be boiled. It needs more energy to be boiled. Okay? That was everything about the vapor pressure lowering. I'll leave this. So now read the following points. I think you must be equipped right now. You must be equipped with enough information to understand the following lines. Look, vapor pressure of solvent containing, vapor pressure of solvent containing solid, it means solution. Very good. Is solution must be, vapor pressure must be lower or higher? Lower compared to pure solvent. Easy. Or vapor pressure of pure solvent. Pure solvent must be higher. Higher compared to the solvent contained solid. This is solution. Very good. Why? Because as the number of, as the number of solid particles increase in given volume, the solvent particles are decreased. So fewer solvent particles will be available to become vaporized. So vapor pressure must be decreased. That's all. Look, why vapor pressure lowering is a colligative property? Because it will change with the change in concentration. That's all, not the identity. Look, let me tell you something very important here. So now I will prove why the colligative property depends on the concentration, but not the identity, not the type, not the name, not the class of the compound. Look, 1 molar aqueous solution of non-electrolyte glucose. So we have 1 molar glucose. Very good. And we have, look at this, where's the other one? 1 molar solution of sucrose. We have 2 different solutions. Let me highlight both. Look, the first solution is glucose. The second one is sucrose. Are they the same or different? They're different. Glucose in where and sucrose in where. But their concentrations are the same. So which one is important for us? The concentration or the type? The concentration. The type, the identity is not important. So they have the same effect. Because they have the same concentration, they must show the same effect. Both are decreased vapor pressure of water by this number in the unit of ATM at 25 Celsius degree. Easy? Very good. Let's keep going. So as the concentration increases, vapor pressure must decrease. That means the greatest concentration, the minimum vapor pressure. Look, which of the following solutions has the lowest vapor pressure? Mister, lowest vapor pressure, it means maximum concentration. Compare the numbers. 0.5, 0.2, 0.02. Which one is the great? This one. This has the minimum vapor pressure and this one has the maximum vapor pressure. Keep going. So now, قطعة تمشاكي كما كفاش بيش بيدا كم لو بابتي نامي راسخو freezing point explain كم حزم لي بسم الله boiling point دو قاعدين سرج إلى freezing شيء جديد. Okay? So I will leave freezing point for now. After 30 minutes, I'll get back to the freezing point. But for now, I think this is the right time to dive into the boiling point. Okay, let's see. What is the boiling point? Mister, I remember you have mentioned something previously, just now. You said there's an inverse relation between the boiling point and vapor pressure. When we increase concentration, vapor pressure is decreased, so boiling point must be increased. Okay? They're working like this, swimming like this. Okay? Look, boiling point. What's the boiling point, first of all? Boiling point is the point of temperature. This is a temperature. When two pressures are equal. The first one, vapor pressure of the liquid equals to the prevailing atmospheric pressure equals to the ATM, atmospheric pressure. When we have the following pressures by equal amounts, we will say this point is the boiling point. What? Boiling point. So this is called the boiling point when the vapor pressure of the liquid is equal to the atmospheric pressure or surrounding pressure of the liquid. Okay? Look, I will open a new page. Let's see. Before talking about this, as I said, what's the relation between the vapor pressure and boiling point? They are inverse, okay? When the vapor pressure is increased, boiling point must decrease. Or vapor pressure is decreased, boiling point must increase. Very good. Look at this. Anytime if I say why, anything that is related to the increase in boiling point, why the boiling point is increased or why the boiling point is decreased, how to answer these questions. How? Okay? So we have to mention the vapor pressure. You will say, Mister, well, I don't know what's happening in here, but because the boiling point is increased, that means vapor pressure must be decreased. Okay? You see? It's very easy. A very easy topic. Why boiling point is decreased? Okay, again, I don't know why it's decreased, but because it decreased, I have to say, I remember you told me they are inversely proportional with each other with the vapor pressure. Boiling point is decreased, it means vapor pressure is increased. That's why boiling point is decreased. Okay? Good? Very nice. So now let's talk about the rules. The rules of the boiling point are really important. We have two rules. Let me select a different color, red color. Okay. So once you read the question, the math problem question, okay, and you will see boiling point immediately. Write both formulas for the boiling point. So we have two different formulas for the boiling point as a colligative property. Look, the first formula is delta TB equals to boiling point of solution minus boiling point of solvent. Boiling point of solution minus boiling point of the solvent. Pure solvent, of course. Okay? So this must be pure. I'll specify all features about this. And the other rule, delta TB equals to KB times total molar concentration. What? Total molar concentration. But because we'll take this formula for the non-electrolytes as the first part, so I don't say total molar concentration. We will say KB times molarity. Okay, so let's explain some important notes about the following formulas, the following rules. Look, first of all, their units of measurement. Look, this is Celsius degree, Celsius, Celsius. All the points are Celsius. How about this? Oh, this is not Celsius, I'm sorry, okay? Celsius, this is Celsius over molarity. Okay, and for this one, the unit is mole over kilogram. Mole over kilogram. Because if we calculate this, we have to divide Celsius by molarity. So the unit is this. The names. This is called change in. Okay, write the names. This one, change in boiling point. What? The first name, change in boiling point. Write the following names. The first one, change in boiling point. The second one, boiling point elevation. What? Boiling point elevation. The third one, boiling above normal boiling point. boiling above its normal boiling point. Look, I'll repeat the three names. The first one, changing boiling point. The second one, boiling point elevation. The third one, boiling above its normal boiling point. Okay? Boiling point of pure solvent. This is pure. Okay? If it's water, so the boiling point of pure solvent, you should know this is 100 Celsius degree. Okay? How about this rule? Delta TB. Again, it has the same three names as here. KB, this is called molar freezing point constant. What? Molar freezing point constant. And you know everything about the molality. Molar freezing point constant for water is 0.51 Celsius over molality. Good. About the molality. This is impossible to get this number by negative. It's always positive. About the arithmetic sign is, it's positive always, positive always, positive always. This is positive always. Okay, the boiling point is same. That was everything about the two rules. The first rule, boiling point of solution minus boiling point of solvent. The second one, Kb times molality. If the solvent is water, the boiling point of pure solvent, you should know, which is 100 Celsius degree, and Kb is 0.51 Celsius over molality. Let's solve some questions together. I've explained all of them. Don't worry, my dears. Okay? Believe me, I have explained it. Even I gave more detail than this. Let's read the first question. The first question. If the boiling point elevation of an aqueous solution, so if the boiling point elevation of an aqueous solution containing non-volatile electrolyte is one non-volatile, must be non-electrolyte, okay? Change this into non-electrolyte. I will add this, non-electrolyte, okay? Must be non-electrolyte. Is 1.02 Celsius. What is the molality of the solution? Molality of the solution. Look, what is this value? Boiling point elevation. So this is delta TB. Okay, we have delta TB, which is 1.02 Celsius degree. Calculate molality. Find the molality. Okay, so which rule contains molar concentration? Delta TB equals to Kb times molality. That's why I changed this into non-electrolyte, because we're going to face some problem here. So it must be non-electrolyte. This is something like a typo. It was a typo, my dears. Take this easy. Delta TB equals to 1.02 because, look, the solution is aqueous, so the solvent is H2O. Kb, you should know, this is 0.51 for water. 0.51 times molality. Divide both sides by this. Okay? Molality equals to 2 mole over kilogram. This is the molar concentration of solution. Okay? We have delta TB here. Good. And then the solution is aqueous. Since the solution is aqueous, the solvent must be used for the dissolution process. And the solid is non-electrolyte, so we will use the second formula. Simply, we have delta TB. Kb is known because the solvent is water, so Kb is 0.51. Just divide delta TB by Kb, you'll get the right number of molality. Another question. Look, what is the boiling point elevation? The sign? Boiling point elevation, this is delta TB. So what's the value of delta TB? Of a solution made from 20.1 grams of non-electrolyte solid. Look, the solid is non-electrolyte. Very good. So this is mass of the solid in 400 grams of water. This is mass of the solvent. Look, as I told you, for solving any question related to the molality, we should specify, identify the solvent and solute. So this is solute, the question said. This is solvent. Solute must be in mole. Solvent must be in kilograms. Very easily. So let's calculate mole and kilogram first. Or wait, I'll give you something like a better idea. The molar mass of the solid is 62.0 grams, and then find the boiling point of the solution. So the first one, we should calculate delta TB. Let's write both formulas of delta TB. Let me select a different color. The formula for the delta TB equals to Kb times molality. To get this, do we have Kb? Yeah, mister. The solvent, look, the solvent is water. So Kb is 0.51. Good. How about molality? Because we need to find out this. We don't have molality. Molality equals to mole over kilogram. But you know, to get molality, we have neither mole nor kilogram. Okay, we have something extra. We have some extra information. We can turn them into the following information to get the right number of molality. So let's find out mole first. We don't have anything like mole. Mole equals to mass over molar mass. Okay? Mole equals to mass over molar mass. Mass equals to 20.1. Molar mass is 62. So use your pink calculator, you'll get the right answer. The right answer is 0.3224. Yeah, I think it's the right answer. Yeah. Believe me, this is a very nice calculator. Mole. Now this is the mole number of the solid, and then let's find out the kilogram. Kilogram, because we don't have kilogram. We should find out. We should calculate it. 400 divided by 1,000 equals to 0.4 kilograms. Mister. Now, kilogram and mole number are both ready. Let's calculate the molality. Molality equals to mole over kilogram. Mole is 0.324. Kilogram is 0.4 kilogram. So the result is 0.81 mole over kilogram. So now we have the right value of molality. Let's substitute this number here to get what? Delta TB. So delta TB equals to 0.51 times 0.81, right? 0.51 times 0.81. Delta TB is equal to 0.41 Celsius degree. This is the value of delta TB. And then find the boiling point of the solution. Find the boiling point of the solution. So that means we should use the second formula. Delta TB equals to boiling point of solution minus boiling point of solvent. Delta TB is 0.41 equals to boiling point of solution is what? We don't know. We should find out the boiling point of solution. BP of solution minus the boiling point of, okay, mister, we don't have boiling point of the solvent. What are you waiting for? I told you. Because the solvent is water, so the boiling point of solvent must be 100. This is 100. And now, try to add both numbers. This is negative. Transfer it to the other side. Boiling point of solution equals to, oh my God, equals to 100 plus 0.41 equals to 100.41 Celsius. بۆ شێوازی پرسیارەکە حەل دەکەی زۆر ئاسانە. ئۆکەی؟ با لە بۆ دووبارەکەمەوە. دووبارەکردنەوەی چ بابی من. ڤیدیۆیەکەی بگەڕێنەوە بەخۆی دووبارە دەبتەوە. ئۆکەی؟ ئەوە سەبارەت بە بۆیلینگ پۆینتی. بۆیلینگ پۆینتمان تەواو کرد.
کەرەستەکانی سەرکەوتن پرسیارکردن چەندین توێژینەوە لەبارەی گرنگی پرسیارکردن و دروستکردنی پرسیار نووسراوە بۆ فێرخواز یا ئەو کەسەی دەیەوێ خوێندنەوەیەکی پڕبەرهەمی هەبێ. نووسینی پرسیارەکان وا دەکات کە زیهن بە دوای وەڵامەکاندا بگەڕێت و هەستیار بێ لەبارەیانەوە. تا پرسیار زیاتر بێ وەڵام زیاتر دەبێ. بۆیە هەوڵ بدە بە پێی بابەتەکە دەست بە پرسیارکردن بکە و بیان نووسە. ئەمە دەبێتە هۆی ئەوەی کە زۆرترین تەرکیزت دەبێت لە کاتی خوێندنەوەی بابەتەکە، چونکە تۆ ئامانجی خۆتت لە سەرەتاوە دیاری کردووە. بە شوێن وەڵامی پرسیارێکدا دەگەڕێیت و بەردەوام بە شوێن